Okay, the last one was the magnetic field of an infinitely uniform surface, number 4, flowing over the XY plane. In that case, I have to define what I mean by, so far I've only done currents that are flowing through wires. Now, what about the case when currents are not over a wire, but in fact over a surface? Do you remember what we did when we did that? What did we call that? We called it a K for current. I think here. Moving it over. When current flows over a surface, we called it current per unit width as surface current density. Right? That's what we talked about. We called it a K. So now that I want to do Ampere's law over a surface, may I write this as infinite uniform surface current K over an XY plane? May I write that as, so let's say this is my picture. This is my surface. It is in the XY plane. So I'm going to be able to say that, right? X, Y, Z. So how will I write my Ampere's law? Well, first of all, I have to pick an Amperian surface. So my Amperian loop in this case would be something like this. Think of it as above and below the surface. So I have a loop above and below the surface. So I can write my Ampere's law as this. Let's suppose that my Amperian surface has a length L. It's half above and half below. May I write this as B is constant. So may I write this as the current enclosed in this loop, is it KL, where L is the length of my loop? Now, what is the B field for segments, let's say A, B, C, D? What's the B field in the segment A to B? Well, there's a B field there. What about for segments C to B? There isn't any. What about from C to D? Yes. What about from D to A? Again, going back to the same logic, right? So may I write this as B times L plus L, the only two segments that matter, the top and the bottom, right? Just like we were doing here. So I'm not going into all the details, right? It's pretty much the same thing. Here, which was the only segment that mattered? This one. And in this case, what's the only segment, what are the two segments that are going to matter? The top and the bottom, which will be equals mu KL, or B2L equals mu naught KL. These two will go away, and I will be left with mu naught K over 2. Most textbooks write this in two forms, one for positive X and one for negative X. B will be plus mu naught K over 2, and B will be minus mu naught K over 2. J hat, J hat in vector form.